Is it recording? Yes. Okay, so we're gonna do some pancake flips. Pancake flips are tough, but I feel like once you get them down, then it's difficult to unsee. So pancake flips change everything from up to down or down to up. And that just means that if you're starting with your substituents being up, they're gonna go to down and vice versa. And I feel like starting with knowing what you have to work with in chair structures is also beneficial. So there's 3 different kinds of every position on a chair structure. You can either have axial up, 3, axial down, 1, 2, 3, a different color, equatorial up, 1, 2, 3, or equatorial down, 1, 2, 3. If you know this structure, then you're basically halfway there. That's ugly. You're basically halfway there. So we're gonna do some practice problems, and then hopefully this will be a little bit easier on you. So we start with a chair structure, and we're thinking about flipping it over the x-axis. And sometimes you can say, oh, lol, I'm gonna flip it over the y-axis. Don't do that, because if you flip it over the x-axis and things still aren't in the right place, all you have to do is turn the molecule. Because if the only thing that's differentiating your molecules is whether or not they're on the right carbon, but they're still equatorial, they're still axial, still in the number in the same direction, then you're fine. Flip it this way. This is easier. So if I have a molecule that looks like this, and I'm flipping it over the x-axis, that means that this bromine is going to start here and end up down here. So instead of being up axial, it's going to be down axial, like that. And that's it. We're going to do a bunch more examples, so if that didn't make any sense to you, I'm sorry. And we'll keep going. So here's another example of one that's equatorial. We'll also put an OH group here and a methyl group here. So when we turn it, think about what we're starting with and what we're ending with. So our bromine is up and equatorial, so that means now it's going to start here, end here, and it's going to be down equatorial. Right there. Our OH group is up and axial, so it's going to end up down and axial here. It's really bright, sorry. Methyl group starts down axial, so it's going to end up axial right there. And you really just think about how when you start with a molecule, these 2 carbons are related, and similarly all of these, this is the same carbon by the way, these carbons are related. So depending on what you're starting with, that can help you get to your final answer. So we'll do an example where we only have stuff on the 4 purple carbons. I'm going to put a bromine here, an OH here, a smiley face here, and a frowning face here. So when I flip this, very scientific by the way, having smiley faces as substituents. Different colors. My bromine's going to go up here. It's down axial, so it's going to be up axial here. This smiley face is going to go to the bottom right of the chair. This is the bottom right. Instead of being up equatorial, it's going to be down equatorial. Similarly, this frowny face is on the left corner, so now it's going to be on the left corner of the chair structure here. Started as down equatorial, so now it's going to be up equatorial. Now we have the OH one. This is up axial, so now it needs to be down axial, the top left. Ta-da! We'll do a couple more. And for these, try to work them out faster than me. So I'm going to put one here, here, and one here. Flip it. I know that my heart is up equatorial, so it needs to be down equatorial. My smiley face is up axial, so it needs to be down axial. My star is up equatorial, so over here it needs to be down equatorial. And now we'll do an example that can kind of help you be less scared of messing up. So the whole point of doing a pancake flip is to make things go from up to down or down to up when you're not starting with things in the right orientation. So what if I have a bromine here, a CH3 here, and I'm worried about putting them in the wrong place? Well, based on how chair structures are built, it's kind of foolproof. So this bromine needs to be down and axial. The only down axial positions available on a chair structure are in 3 different places. One of them is here, one of them is here, one of them is here. And we flip across the x-axis, it's going to go here. So that means that this needs to go here. I can't put it here because there's no axial down position here, because the only thing that's available is up axial or down equatorial. So let's do the same process with our methyl group. So our methyl group is down equatorial and it needs to be up equatorial. Flipping it across the x-axis, the only upward equatorial positions available are here, here, and here. So if I'm going across the x-axis, literally from here to here, then that means that it's going to go on this down carbon, on this bottom carbon, and it's going to go up equatorial, like that. So that's why I say that it's important to know where your axials and equatorials are on chair structures, because it'll make this a lot easier for you. So looking through these problems, know that pancake flips go from up to down or down to up. You're flipping across the x-axis to get from one thing to the next. If you know where things can be axial and where things can be equatorial, then your life is a lot easier. You can do one substituent at a time, like how we did with our OH, did our bromine next, did our methyl group next. You don't have to do them all at once. Whatever is easiest for you. You can make it fun and interesting. If you have a really scary substituent, like a big bulky base is starting to attack or something like that, you can make them fun. Use a smiley face, use a star, use a heart, and I hope that helps.